Hello friends, myself VV Gonka, Assistant Professor, Sales from Technology, Ichatpuri. So today in this video, I am going to discuss about Fourier Integral representation. First we will see the formula for Fourier Integral representation. The Fourier Integral for f of x is f of x equal to 1 upon pi integration 0 to infinity integration minus infinity to plus infinity f of t cos lambda into t minus x d lambda into dt. So this is the formula for Fourier integral of f of x. Let us see one note while evaluating the integral. If the function is discontinuous, then if x is point of discontinuity of the function f of x, then the integral is the mean value of right hand and left hand limit. That is 1 upon 2 f of x plus f of x minus. So now we will take one example based on the formula. Express the function f of x is equal to 1 when mod of x less than or equal to 1, 0 when mod of x greater than 1, as Fourier integral, and hence evaluate integration 0 to infinity sin lambda into cos lambda x upon lambda into d lambda. So in the first part we have to express the function f of x as Fourier integral. In the second part we have to evaluate this integral. Solution. So first we write the formula. Fourier integral is f of x is equal to 1 upon pi integration 0 to infinity into double integration, this is minus infinity to plus infinity, f of t into cos lambda into t minus x dt into d lambda or d lambda into dt. So here f of t is nothing but the given function f of x. Solution. So one more thing we have to remember, mod of x less than or equal to 1 is nothing but x lies between minus 1i plus 1. So mod x greater than 1 is nothing but other than this range. So now I will divide this integral by using properties of definite integral. So f of x equal to 1 upon pi, I will write as it is integration 0 to infinity d lambda. So I split this integral like minus infinity to minus 1 f of t cos lambda into t minus x into dt plus minus 1 to plus 1 f of t cos lambda into t minus x into dt plus 1 to infinity f of t cos lambda into t minus x into dt. So mod x less than or equal to 1 is nothing but x lies between minus 1 and plus 1, and mod x greater than 1, it means the range is like this, minus infinity to minus 1 and plus 1 to infinity. So mod x greater than 1 is nothing but this range. In this range, the function value is 0. So in between minus 1 to plus 1, the function value is given as 1. Therefore, f of x is equal to 1 upon pi integration 0 to infinity d lambda. Here the function value is 0, and in last integral also the function value is 0. In between minus 1 and plus 1, the function value is 1. Therefore, remaining is here minus 1 to plus 1 into cos. So we take this lambda inside the bracket. This becomes lambda t minus lambda into x into dt. So f of x is equal to 1 upon pi integration 0 to infinity into d lambda. Integration of cos is sine, that is sine of lambda t minus lambda x into derivative of lambda t minus lambda x with respect to t. Derivative of lambda into t is lambda, and derivative of this one is 0. Here remaining is lambda between minus 1 to plus 1. So therefore, f of x equal to 1 upon pi 0 to infinity d lambda upon lambda. So now I will put here upper as well as lower limit. Instead of t, upper limit is 1, remaining is sine of lambda minus lambda x minus lower limit sine of, if I put here t equal to minus 1, it becomes minus lambda into x. Therefore, f of x is equal to 1 upon pi 0 to infinity 1 upon lambda into here. So here I will take minus common inside the bracket. So it becomes sine of minus lambda plus lambda into x. If I take minus inside the bracket, and we know that sine of minus theta is plus sine theta. Sorry, sine of minus theta is minus sine theta, and this becomes positive. So that is sine of lambda minus lambda into x plus sine of lambda plus x into d lambda. So now I will simplify this one. So we know that sine of a plus b plus sine of a minus b is nothing but 2 times of sine a into cos of b. So here, so this is a and this is b, a plus b. Again this is a and this one is b, a minus b. So I will use this formula. So therefore f of x equal to 1 upon pi integration 0 to infinity 1 upon lambda 2 into sine a. 2 into sine a is nothing but lambda. 2 into sine a cos b. Cos b, b is nothing but lambda into x into d lambda. So this is the Fourier integral representation of the given function. So our second question is we have to evaluate the integral. So therefore now I will take this pi to LHS. So remaining is 0 to infinity. Here 2 is constant. I will write outside the integral. Sine lambda into cos lambda x upon lambda into d lambda is equal to pi into f of x. So integration, now I will take this 2 to RHS 0 to infinity sine lambda into cos lambda x upon lambda into d lambda is equal to pi upon 2 into f of x. So now here we have to put the value of f of x. While evaluating the integral, we have to see whether the given function is continuous or discontinuous. If the function is discontinuous, then f of x is nothing but the given value, and if the function is discontinuous, then you have to take mean of left hand and right hand limit. So here, so I will plot the graph here. This is minus infinity. So I will take here minus 1. This is plus 1 and this is infinity. So here along x axis I will take the values of x, along y axis I will take f of x. So our given function is like this: f of x equal to 1 mod x less than equal to 1, 0 mod x greater than 1. Mod x less than equal to 1 is nothing but x lies between minus 1 and plus 1. Here for minus 1 to plus 1, the value of f of x is 1. So I will take here some 1 centimeter. For x minus 1 to plus 1, the value of f of x is 1, that is along y axis. So mod x greater than 1 is nothing but x lies other than this range. Means in this range and in 1 to infinity range, the function f of x is 0. So it lies on the f of x is 0 nothing but the x axis. So we can see here the function is discontinuous. At this point the function is discontinuous. Therefore f of x is discontinuous at x equal to 1 and x equal to 1. Therefore equation number 1 becomes integration 0 to infinity sin lambda cos lambda x upon lambda into d lambda is equal to pi by 2. So if the function is discontinuous, then you have to take left hand and right hand limit, that is limit of f of x as x tends to 1 minus limit of f of x as x tends to 1 plus. So 0 to infinity sin lambda into cos lambda x upon lambda into d lambda is equal to pi by 2 x less than minus 1 is nothing but more x lies between minus 1 and plus 1. In that the value of f of x is 1 plus, so here I have to mention one more thing. The formula is like this. This is 1 upon 2. Formula is mean of left hand and right hand limit. For that I have to write here 1 upon 2. So here also this becomes pi by 4 plus x1 plus, that is right hand limit. Between this range the function value is 0. Therefore integration 0 to infinity sin lambda into cos lambda x upon lambda into d lambda is equal to pi by 4. So this is our required result. So in this video we have seen formula for Fourier integral. Then we have taken one example. In the first part of the example, we have expressed the given function as Fourier integral. In the second part of the example, we have evaluated this integral. And while evaluating the integral, we came to know the function f of x is discontinuous. Therefore, we have taken here the mean of, that is 1 upon 2, limit of left hand limit plus right hand limit. So, thank you.